Hello and welcome to this video on simplifying trigonometric expressions. The portion of this lesson or this video is only going to focus on the concept. And I want to start off this lesson talking about your prior knowledge with the Pythagorean theorem. Now, we are aware that the Pythagorean theorem is a squared plus b squared equals c squared. So if I take this idea and I let this side of a right triangle in the unit circle be A, and I let this side be B, I can adapt the Pythagorean theorem to be x squared plus y squared is equal to the hypotenuse squared, which is 1 squared. Now, we're aware from our work in the unit circle that our x value, this is cosine, and our y value is sine. So if I just do some direct substitution, we now have this formula. Cosine of theta, whatever theta being this angle here, cosine of theta squared plus sine of theta squared is equal to 1. Now, cosine theta squared, this is cosine squared theta, and sine theta squared is sine squared theta. So we get what we're going to be working with a lot in this unit, which is our Pythagorean identity. And this is a very, very important idea in this unit. So we get cosine squared theta plus sine squared theta is equal to 1. Now, if I just shuffle this, because kind of intuitively when we work with SOHCAHTOA, we tend to think of this order generally, right? Sine, cosine, and then we have tangent. But I'll just shuffle these two trigonometric functions to give us our Pythagorean identity. And this is very, very important. This is our Pythagorean identity. Okay, sine squared theta plus cosine squared theta equals 1. And I'd like you to go ahead and say that out loud. Sine squared theta plus cosine squared theta is equal to 1. So building on this identity, we can get our other identities by getting rid of sine and by getting rid of cosine. So from our previous work, right, and our idea of the main 6 trigonometric functions, right, sine is paired with cosecant theta, and cosine is paired with secant theta, and tangent is paired with cotangent. Now, the relationship between these, right, is that cosecant is the reciprocal of sine, and I can write it like this. So 1 over sine theta is cosecant theta, and secant theta is 1 over cosine, and cotangent is 1 over tangent. So if I divide sine squared theta plus cosine squared theta equals 1 by sine squared theta, you agree that this quotient is 1. This quotient here, cosine squared theta over sine squared theta, that is cotangent squared theta. And 1 over sine squared theta is cosecant squared theta. So we get our second Pythagorean identity. That's important. And our third one, if we do the same exact process, but this time divide by cosine squared theta, sine squared over cosine squared, that is tangent squared theta, right? Those are our quotient identities. And cosine squared theta divided by cosine squared theta, that is 1. And if I divide 1 by cosine squared theta, I get secant squared theta. So I get this identity here. Okay, so if I go backwards, this identity here, this is your main Pythagorean identity, and from this one we develop our other two, 1 plus cotangent squared theta equals cosecant squared theta, and tangent squared theta plus 1 equals secant squared theta. Okay, so those are very, very important identities that we're going to be using in this lesson. Along with these Pythagorean identities, we're going to be using our idea of reciprocal identities, okay, and quotient identities. So I talked a little bit about these reciprocal identities, and the quotient identities. Again, tangent theta is equal to sine theta divided by cosine theta, and cotangent theta is equal to cosine theta over sine theta. So this page here is very, very important in your notes. Okay, so look at this page, and then also these identities here are listed for you. And I want to talk really briefly about the other two identities that are listed here. If I take sine squared theta plus cosine squared theta equals 1, and if I manipulate this, if I remove cosine, so I'll go ahead, I'll move cosine. Whoa, going too fast. If I remove cosine squared theta to the other side, I get sine squared theta is equal to 1 minus cosine squared theta. And we'll see some examples. So that is this example here, how I developed this Pythagorean identity, and then I'll talk about here cosine squared theta. So again, if I use sine squared theta plus cosine squared theta equals 1, now if I subtract sine to the other side, now we get the second identity here, which is cosine squared theta is equal to 1 minus sine squared theta. So we'll be using all of these identities. It's a lot to kind of wrap your head around. So what I recommend to you guys is to use flashcards. Flashcards are a great study tool. On one side, right, on the front, go ahead and write sine squared theta plus cosine squared theta, and on the back of the card write 1. Okay, so I would use that for this one, and then just develop the other flashcards. So you can do 5 flashcards for all the Pythagorean identities, and then you also have the reciprocal identities and the quotient identities. That would be good to develop flashcards for if you struggle with memorization. All right, so here is the concept video, and again, we really focused on this portion of the lesson on the Pythagorean identities, how we developed the Pythagorean identities, going forward, and just kind of how they came about. So like the video, give it a thumbs up, and the videos to follow will focus on examples and how we actually apply this in our objective, which is simplifying trigonometric expressions. Next time.